several faults. So it's not only strike slip faults, but also it got trends or North Sulawesi trends in the north. And then if we see the plate movement at the moment, so Sulawesi are located into like in the middle of different plates like Caroline plate, Philippine Sea plates, and also Indo-Australian plate. Based on the recent GPS data, we can see that maybe we can think that mainly Sulawesi is like a convergence area that always pushed by different plates around Sulawesi, but we'll see whether it's true or not. And then because of that, because of this present day setting, Sulawesi commonly interpreted as a result of the multiple collisions. And we're going to check whether it's true or not. So still some regional information about Sulawesi. This is the latest data that I download from the USGS. You can see here based on the seismic reflection data that Indonesia, interestingly, have a relatively thin crustal thickness compared to other areas that have like, really thick craton. So, and especially in Sulawesi, you can see with the like the light green color here. So it's like even thinner, like maybe in between 20 to 25 kilometers crustal thickness. So at the moment, we can see that in regional area, Indonesia mainly is a stretch crust. So it's like a unique place where the crust is not really that thick. And then this, of course, will implicate to the history of the geology, of course, and also for the for the resources that might be in Sulawesi as well. So now we are going to Sulawesi. Here we can see the DEM or digital elevation model data. You can see that there are like really high mountains and also really deep basins in Sulawesi in a relatively like a short distance, and this peculiar K shape also caused by the several faults. And here the tectonostratigraphic provinces of Sulawesi that commonly we refer to. So it consists of North Sulawesi. It's commonly considered as a volcanic arc segment. It's quite young, so maybe like started in Pliocene, where the North Sulawesi trends is formed in the northern part of Sulawesi. And then also we got part of the continental margins, and we got Central Sulawesi here. So Central Sulawesi always uh, considered as the Central Sulawesi metamorphic belt, and we later will check whether it has like Cretaceous or even younger ages. And this is the East Sulawesi Ophiolite. So part of Eastern Sulawesi is considered to be Ophiolite sequence. We're going to check that as well, whether it's true or not. And the last, there are also continental fragments that was part of the Australia or called as a Sulaspur. So these relatively simple settings will might us to think that Sulawesi is basically, results of the simple like convergence setting geology. But where we see that in the field, or we can see in the details that not the case. So these relatively simple tectonostratigraphic provinces led to an interpretations that Sulawesi was formed by accretions and also always by the convergence mechanisms. And this also overlooks the role of extension. So later I'm going to explain why extension is become like really important in Sulawesi. And the last thing is about the tectonic events in Sulawesi. So there is a debate about the collisions, the recent collisions that happened in Sulawesi, whether it's like Miocene or even in Pliocene. So that was one of the questions that I need to answer when I did my PhD. So in that time, I tried to answer it by finding the timing of depositions, why it is called as the syllabus molas. So syllabus molas was considered as the post-collisional sediments of the collision event. So when we talk about the collision, there are some other hypotheses that have been thrown by several geologists. So the first one here, we can see there's a reconstruction by Silver and Smith. There are two reconstructions here that showing the formations of Sulawesi. But in the middle here, this is the oldest hypothesis about how the part of Australia got into Sulawesi. It's by Hamilton. It's called as a bacon slicer. So it's moved to the northwest by the strike slip fault here. And here, down here, there are another hypothesis as well that there are like two different blocks of Australian fragment that collided in Sulawesi. First is like in Miocene, and then later in the Pliocene or Pleistocene. That kind of similar in here, but in the different time. First is fragment that first come is in middle Miocene, and then later there are more slices of the fragments that come into the late Miocene, this one here it's from Villeneuve, and then it is says that there are two blocks of Australian fragment. The first one is Tokala block that uh, arrive in upper Miocene to lower Pliocene, and then the last one is the Banggai Sula block that arrive in upper Pliocene. So there are some questions about the timing of collisions, and that why the syllabus molas was proposed to determine of the age of collisions. And you must be very familiar with this, but there are some things that have been overlooked by most of the people. This is Robert Hall reconstructions from 20 million years ago to the 1 million years ago. If you can see here, at 20 million years ago is the first time that Sulaspo arrived in Sulawesi. And you can see it's part of North Arm as a part of a volcanic arc. And East Arm here, the green one represents the part of the Ophiolite, and then the red one here is part of the Australian fragment, while the yellow one is part of the Sundaland. And if we see in the 15 million years ago, in these reconstructions, there is a rollback that happened this time. So it's basically I will explain this like further for who's not familiar with the hinge of the subduction here. That's not not in the like northwest directions, but rather to the southeast direction. So it's following the Banda environment here. But no worries. If there's a question about rollback, I'll explain it in the later slides. And this is the thing that I want to highlight. If you see all of this reconstruction here, the collisions that happen is like only in 20 million years ago. So, and after that, if you see like here in the 10 million years ago, so North Banda Sea is started to form even in 8 million years ago. You can see the blue color. The blue color in here represents the oceanic crust that formed after uh, the Australian fragment like dispersed. So it's like, you know, because of the or extended crust, or the extended crust that created the oceanic crust in here. So I commonly see people like trying to like overlook this and try to mix up what the understanding of Pliocene collisions, and then with this Robert Hall's reconstruction. So if you see here, so there is no Pliocenes here in 5, so there is no Pliocenes collisions happen in Sulawesi. So after 20 million years ago, what really happened in here is like it's more dominated by the extension. Although there are subduction that keep like rolling back or moving to the southeast. So it's not like a common or the normal subduction that will usually going to these directions, but this going to this direction. One of the reasons why this happened, because you can see that this green color represents the older oceanic crust. So it's, we know that this part of like, you know, Mesozoic rocks, and then if we compare the oceanic crust, the blue and the green one, the blue is like slightly older, while the green one is slightly sorry, the blue is slightly younger, and then the green is older. So there are like different densities that might uh, uh, make the rollback is easily happen, because this one is like, you know, denser, or okay. And then there's some of the summary about the age of the how the subduction moving. So we can see that this is the part of the Java trends that now is the Banda. It's going to like move southeast, and you can see also Sulawesi also kind of similar. There's a rollback where it's like moving towards north. So there are 3 main points that I want to highlight. First, there's a solar spore collisions about like early Miocene, 20 million years ago. And then the peak of extension time is about 15 million years ago. And there's also a North Sulawesi trend rollback that started in 5 million years ago. So hope it's working. Okay. Mm. Okay, now you can see when it's moving north, you can see around like 20 million years ago, it started to collides, and then and you can see around this time, you can see this subduction is not moving northwest, but rather like open towards the southeast. And here the blue area is the North Banda Sea, and later is the South Banda Sea is formed. And this is uh, the present day Weber dip. So if you see the condition at the moment, so Weber dip is kind of a four arc basin. So here once again we can see the how the rollback happening in Banda. You can see this yellow is part of the Sundaland. You can see, and here you can see starting 5, it's also not moving northwards. So it's North Sulawesi trends. Okay. Now, enough about the regional geology. Now, I'm going to give some evidence about the geology of Sulawesi that might give us a better understanding. There are a few questions that I want to address tonight. The first one is about the extent of a continental basement. The second one is about the Central Sulawesi Metamorphic Belt that can give us hints about the subductions in Sulawesi. And there's also about the Ophiolite. The fourth one is about the extension role. I'm going to give several evidence as well about the extension that happened in Sulawesi. And the last is about the syllabus molars that can give us about the timing in Sulawesi. So this is more like not that more like, let's say, is accommodating the complexity of Sulawesi. So here the new geology that I propose here. So first is about the extent of the continental crust. Here I'm going to give some evidence based on the zircon dating. So previously we thought that only Sula and then Tukang Besi platform that belong to Australian fragments, but the recent data from the field indicating that there might be bigger area of the Australian fragments within Sulawesi. So here there are peak of Triassic and Jurassic rocks that correlated with the what with in the birth heads as well. So, and this is the location where this zircon dating was collected. So we can see here in the east arm also contains of the inherited zircons that uh, possibly belong to Australian fragments. So I would propose that the extension of the Australian fragment might be larger than we thought before. And this is about the timing of collisions, like I've explained before. So the timing of collisions is always a debate whether we can date that in a very short time. So here's some reconstructions that have been done by Robert Hall and also Jonathan Pownall here. So the collisions only happen once here in the early Miocene, and then it's later followed by the rollback and extension since at least since the 15 million years ago. And this is the first evidence that I got from the field. So this located in the northern part of the southeast arm. It's in Tanjung Losoni, and then here I can date it several limestones that can give me Buddigelians or about like uh, 19 to 17 million years ago, and this has become the first evidence that there is uh, rocks or that post date the collisions in Sulawesi. So uh, uh, here some of the rocks with the components, and I didn't do it by myself. I get help by Marcel from UCL. So yeah, thanks to Marcel's. And the thing that I also want to let you know that this area have been visited before by the Dutch geologists Van der Vleck and Dozy, and they also found evidence that this rock is possibly has early Miocene age. So this is the unpublished report that written by Van der Vleck and Dozy. And you can see in these locations, he found several carbonate rocks, and you can see there are some words that I underlined by red. And then the thing here, you can see that even this is limestone, there are also some terrigenous material get into the limestone. So like this first one, so it got and then even here you got and then serpentine get serpentine and pyroxenes and then chert fragments. So I would say that this limestone is deposited possibly after the collision. So that's why chert and also olivine and serpentines can get into the rocks or to the carbonate rocks. So this is the first evidence that uh, collisions happen. There are some uplift that might happen and then eroded the uplifted rocks like ultramafics and also ophiolitic errated rocks. When they get after that, they get eroded and then transported and then deposited in this limestone. And the other things here, I also got inherited zircon from East Arm. So there are peaks in Neogenes. The first peak is late Oligocene, and then the second peak is early Miocene. So there are two Neogene peaks that are related to the tectonic events where these zircons form, and then there's also a publications by Webrands here. So Webrands found the blue cyst in southeast arm, and he dated the blue cyst, and the blue cyst ages is between 20 and then 20. This indicating that evidence of the early Miocene collisions in Sulawesi. S- Another about when we talk about the abduction and that how that and whether it's collision or abduction, and then uh, how we can interpret and geology history about that. And this that made by Robert Hall, and this uh, is running this. So represent this line, so from southeast arm to the north arm, and then the interpretation here after the collisions, and then it's followed by the delamination where the Sula slab become more vertical as represents in this tomography here. And this is the reconstruction that I proposed. So we're going to check whether it's like, you know, because there is no 100% true in geology. So whether it's like supported by the evidence or if you remember that I talked about the Jurassic Oceanic uh, crust versus the Cretaceous oceanic crust. So for the first time before it got collided, we can see that probably the Jurassic, because it's older, so they're denser and then they tend relatively tend to sink. So just to upper part only. So we're going to talk about that in about this later. So about the subduction evidence, interestingly, I finally found the evidence during the Expedisi Poso trip in I think it's 2019, and here I found this is the green cyst outcrop, and this one the blue cyst outcrop. And interestingly, it found like in the flank of the Pompangio metamorphic complex. So this is the first evidence of the subduction that I found in the field. So I'm quite surprised. First time I saw the blue cyst in Sulawesi. So when we found about that blue cyst, so I think better we also talk about the Central Sulawesi metamorphic belt. So I can say the area where I found the blue cyst, and it's part of the Central Sulawesi metamorphic belt collision here. So if you remember, I talked about the blue cyst that dated by Webrands. So we found the blue seas in here, so in the southeast arm, and I think because there is a different metamorphic belt in here, which is older. And then I think there should be like two different metamorphic belts. So the one is like the one is older, related to the Baru complex here in the south arm, and maybe in the eastern part is like, you know, slightly younger, that represents the early Miocene collisions. And then if we put that in my schematic cross sections here, so we got, you know, blue seas should be, I mean, you know, form in the high pressure and then low temperature area, so we can get it like deeper than the green seas. So we can see this is like evidence of the subduction that's initiated in Sulawesi. So we've got blue seas, and then we also got green seas in the area. So that's the first evidence. The second evidence about the subduction is when I find the garnet peridotites. So I find this garnet peridotites not in here, but I found it like in East Arm. So this is the schematic model of the where the garnet periodite form. So garnet periodites is also interpreted to be related with the subductions, where it is related to the in the mantle wedge the area. So it's a tectonic setting, the mantle derived and crustal hosted garnet periodite. So I found this in Bongka River in East Arm. And another things that I knew before I found the blue seas is I already got a hint from the sediments. So this is the because when I did my PhD, I concentrated on the young sediments, so I'm not really look into the older rocks. And then from the young sediments, I think the age is Lage formation. The age is about Pleistocene. I found like really good, well-preserved glaucophan. You can see here the blue color. I also find kyanite and also zircons in here. So in that time, I would say that maybe someday I will find the source. I mean, because we've got the sediments here that contain glaucophan, so this glaucophan should come from the blue seas rocks. Okay, so that's some of evidence of subduction evidence in Sulawesi. Now we are going into the Ophiolite. So this is the green area that represents the Ophiolites outcrop in Sulawesi. The fact when I went to Sulawesi, it's not that easy to find the complete Ophiolite, although there is a publication by Kadarusman that said there should be a complete Ophiolite in here, but I cannot find it. So most of the rocks in here are ultramafic and some gabbro rocks. So the one that hardly find is the basalts. I never found that during my uh, uh, PhD trip. So it's interesting if we can see this. Uh, is there any really ophiolite in Sulawesi? So about East Sulawesi ophiolite. So I remember, I think it's like in 2017, I got invited to do field work with Pertamina EP by Anggoro. It's Anggoro Kurniawan. I think he's one of the participants in here. So we went to the field to check whether there is a fertilizer or not, and then I can only almost I can only find almost complete of fertilizers only from the boulders or from the pebbles and cobbles in the river. So as you can see here, I can get a series. I can make a series. So this from Kadarusman. So if you talk about Ophiolite, it should be like in the complete sequence. So it started like ultramafic rocks, you got dunite, and then you got ultramafic rocks, and you got gabbros, layered and isotropic, and then you probably will get seated dikes and volcanic rocks, usually represented by basaltic pillow lava, and the end you will get deep sea sedimentary or limestones. And when I did the field work, with Anguro, I can only found several cobbles that represent this East Sulawesi Ophiolites, and that time I couldn't find the volcanic basaltic pillow lava. So the very dominant rocks are peridotites and ultramafics and cherts, and gabbro is common with the micro gabbro as well. Foldaces is rare with the limestone as well, rare. And then interestingly, I found like granitoid rocks in there. So we speculated that might be to the granitoids or plagiogranites that related to the subductions. So, and after that, you can see here it's a beautiful area. It's Pulau Dua in East Am. And if you can see these like small islands here, is actually a layered gabbro. So I'm really surprised and happy when I found this. So we found this during the field work with GOB, Pertamina, Medco, and Tomori. So if you can see here, there's a slight uh, uh, layer of gabbro in Pulau Dua. So it's Balantak. It's like the end head of East Arm. And this is some of evidence of the dismembered ophiolite, because in that time we haven't find the complete sequence yet. And this is the shear ultramafic rocks, and this is the uh, close view of the layered gabbro from the previous pictures that I saw you before. And then we get the layered gabbro in here. So in that time, we are, me personally, quite sure there should be a complete ophiolites in Sulawesi that can be found. And finally, this is Pamunga, one of my students. So he did his mapping here. It's in Poso Depression. It's in central Sulawesi. And he found some evidence of the ophiolites. You can see here, number one is, although it's not really that good, but we can see the more circular shapes that possibly represents the pillow or pillow basalt or pillow lava. And then we got chert, and then here we got ultramafic, and there are some gabbro. So we got this possibly like shear and then faulted. But interestingly, we found this not in East Arm, but we found this in Poso Depressions in Central Sulawesi. So that's another thing that we need to think about, and then I'm going to talk here about later. And then he also, Pamunga did free folk in East Arm, and finally he can find the here the serpentinized peridotite. So it's part of the ultramafic rocks, and this is the location here. Is the southern part of the East Arm. And then he also found that possibly part of the layered gabbro. So if you see here, so we are like walking from the older part of the sequence where we got ultramafic, and then now we are got into the layered gabbro. So this is the highly fractured layered gabbro. And then after that, this outcrop of the possible isotropic gabbro. So we are like getting uh, almost complete sequence of East Sulawesi ophiolite. And then this is the interesting part. Finally, someone found the uh, uh, the city dye complex. As you can see here, that these gabbro are intruded by the basalt dike in here. And this is the special one. So finally, I'm really happy that Pamunga can find this below lava outcrops. You can see here it's this really beautiful outcrop. So I think this is one of the best outcrop that I've seen. I'm on after in Karang Sambung area. You can see this shape really showing the pillow basalt itself. So yes, finally we can get the complete sequence of East Sulawesi Ophiolite in here. So this is the area in southern of the east arm. And this again, another outcrops of pillow basalt, so even clearer in here. So it's amazing, right? So yeah, this is really pillow basalt that uh, we've been looking for. Uh, and this is the upper part. So this upper part is the sediments. So we've got red limestone and also charred that possibly on the top of the pillow basalt is also weighted uh, uh, chert. And this is alternations between the red limestone and also cherts. But yeah, this mostly been folded and folded because the complexity of the is and then yes, so we can basically Ophiolite in Sulawesi. We got the complete one in here, so we go there and see together. Now we're going to talk about extension role in Sulawesi because at the beginning I told you that there's only like one collisional event happened in early Miocene, and then it's followed by the extension role extensions, and then just remind you again. So the extensions mainly started like about 15 to 16 million years ago, and it's not also recorded in Sulawesi, but it's also recorded in Seram by Tan Ponal. So it's like mainly this area will probably recall about the 15 million years ago extinctions, because you can see since that time the trends is moving southeast following the shape of the banda environment here, and it is also causing the extension around the, let's say, the back arc area. You can see there's a, this is North Banda Sea that formed about 10 million years ago, and then there's also South uh, Bandasi that probably younger, about since 5 million years ago. And then up till now, you got Weber Deep in here that is the youngest for arc at the moment. So here's some seismic tomography to help us understand about the tectonics of Sulawesi. So we can see this is the Sula slab, and then we got Sangihe, and the blue one from the north is the North Sulawesi trends. And you can also see from the seismic tomography here, there's a unique arcuate shape of the slab that making like a shoe hole shape in here, where we can talk about it later. And then here another seismic tomography image. So it's called, this is A, it's running east west, and then CDE is basically running north south. And then if you can see the shape in here, if in B, a flat bottom slab, and in C there's a like a U shaped slab. So it's indicating that there's no like two different slabs in East Indonesia. So it's basically the one slab that makes like a bowl or a bathtub shape. And this is the image if we see in 3D. So it's like a, like a half bathtub where the slab is basically like tearing here, and then it's going flat at at the bottom. So this shape is basically like one of the typical shape of the subduction rollback. So basically, this subduction rollback has been proposed by Milsom, but at that time, Milsom only uh, throw the idea based on the stratigraphy. I'm not going to talk about the Mesozoic stratigraphy. So basically, he can correlate the different stratigraphy here. What he calls as the band associations that can be traced from Southeast Arm and then to Serams that make this like a arcuate shape. And he also compared that with the other retreating slab or subduction rollback around the world. So we can see that this like banda C have the arcuate shape, that one of the characteristic of the subduction rollback. And we can see that here is this is the Tyrrhenians, and then we also got the Carpathians. So basically the trends movement is like going to the to the arcuate shape in here. So here's the simple explanation that I want to explain about subduction rollback. So it's basically you got trends here, and then you got subducted slab, then you got overriding plate in here, and then why it called like rollback, because this is, let's say, time 1, and then in the time 2 the slab is not moving like towards these directions, but it's like try to be like kind of moving back, and then that's why it's called the subduction rollback, because the subduction is not moving forward, but it's like it's going back, not forward. And then this causing the upper plate extend to fill space, and then that's when the extension it starts to happen. So there might be a brittle or ductile extension happen in the upper plate, because it's need to accommodate the moving of the subduction rollback here. So yeah, and this is another example. So we got time 1, 2, and 3. So time 1, this is rollback, so subduction is moving like back here, and then to accommodate this, the upper crust needs to be thin, and it's also make the hot mantle rises. So that's why I said in the front that Indonesia is like really different to other areas, because it's like got a thin crust, and then the crust is also stretched. Is possibly because of this rollback that happened in the eastern Indonesia. So the result is like there should be uplift and also subsidence. So when the mantle exhume, there should be like exhumation. So this part should be uplift, and then they're also accommodated by the extensional faults that are creating the basin. So this is like the basic theory to understand what is happening in eastern Indonesia, particularly in Sulawesi. So if we see here, so Hinsberger already dating the North Banda Sea and then the South Banda Sea, and then from his work we know that the North Banda Sea formed between 12 to 7 million years ago. So probably like this is like in the middle Miocene, and then the South Banda Sea is 3.5 million years ago. So it's about Pliocene, and then this is the younger Weber trough. So at the moment, this is the volcanic arc. So we can say this is the fore arc, and then we've got the back arc here. So we can, if we see this cartoon diagram, we can imagine that this is possibly the extended oceanic crust that part of the Banda Sea Basin, and Sulawesi probably like this in this area. So there should be like lithospheric thinning and also extension, there will be like intrusions happening in or have been happened in Sulawesi to accommodate the movement of this banda rollback. And this is some of the examples. So this is part of the Central Sulawesi that previously I called this where I found the blue cyst in Popamgeo cyst complex, and I found the sediments that contain glaucophan in this lage formations. So lage formations like Pleistocenes, and actually I took this outcrop like after I made this model, so it's kind. I'm really happy that it's like my model is like kind of a work in here. And in the field, we can see that this is lage formation, while this is puna formations. And just like in the model here, the puna formations like cut by several normal faults. So these normal faults possibly related to the exhumation of the Pompangio cyst complex, and this and that's why the lage formations can contains lots of glaucophan, because in that time the blue cysts have been exposed in the very and yeah, back again here. So if we see this and this, so the one that we see before is like these conditions, so where all the metamorphic rocks have been exposed. And this is from the previous pictures where this like it should be formed like beneath under with the high pressure, and then now it got into the surface, so there should be exhumation happening or going on. And one of the explanations that I propose is there should be a slab break off, and then also isostatic rebound after the collisions happening. So that makes these metamorphic rocks appear or expose in the surface. And this also could be the reasons why there is a abduction. So this idea is possibly can explain also about the abduction that happening in Sulawesi is because of this exhumation related extension. And then because I got this normal faults in this part, so it's like in the Central Sulawesi, or in this is Pompangio complex. So this is the western part, and then this is the eastern part. So I'm interested to go to this eastern area to check its correlations with the western part, and whether it's also correlated with the what happening in the east arm or in the Tomini Bay in here. And then fortunately I can go to there again with Pertamina EP. Thank you, with Angga and Agung in that time. And then I'm going to show you evidence from this part. So from this Pompangiosis complex towards the towards this area, towards Nanaka Island. So there are like Nanaka Island here. So we're going move from let's say from Pompangio complex towards the southeast. So in the Pompangio complex, I found several evidence of the extensional faults, and this is the serpentinized peridotite, and I can see there's evidence of the extensional faults in there. So evidence of extension again in this area. I also found evidence of extension that cuts the ultramafic rocks, and this also still in this area there's evidence of extension that cut. This is mapped as a Tokala formations. So this Tokala formation is about Mesozoic in age. And now we are going to towards Colonodale here. So this is Matano formations. You can see this is the limestone. So Matano formations is okay. Now we have got into the Tambahu formation. Is still part of the Mesozoic rocks. And here we got into Nanaka formations, still the edge of Mesozoic, and there's indication of the thrust faults in here. And this is clearly showing the thrust faults in the Nanaka Island area. It's really sarcastic of the Tambahu, but it's has kind of similar edge with the Nanaka formations as well. And you can see the thrust faults here. And still, this is in another part of previous area. You got evidence of the thrust faults. And this is part of the Tokala limestone. It's got the Triassic in age. This is still Tokala limestone. And this is part of the Matana formations. Got Cretaceous ages. So it's chert, and then it's got highly trusted and folded in the east arm. So if we can see here, I got evidence of normal faults, but I also got evidence in normal fault in here. So it's basically, this represents the core complex that exhume. So when the core complex exhume, the upper part is just like slide off downwards. So this is the schematic cross section. So when the metamorphic core complex form, so the upper parts is like to accommodate the movement, vertical movement. So it's kind of a slide off, and when it's like sliding off, there should be they could be create like the thrust fault in front of it, and then that's the things that I can propose looking at the data, because we've got normal faults here, and then we got thrust fault in the short distance in here. So there should be relation with these exhumations of the Pampangio core complex here. So that's possibly the relations between the exhumed Popangio metamorphic complex with the fault and thrust belt in the Matindok block area in here. So this is the seismic. So this is modified seismic. We can see this is the evidence. So this probably like running this way, and you can see there's a thrust fault that got the Ophiolite. So the idea in here, because we've got Mesozoic rocks here, so the 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 ultramafics is possibly slide or detach over the Mesozoic rock. So this is one of the idea that can be a good implication in terms of oil and gas exploration. So and it's, if we relate again about the extension of the Australian fragment. So there should be there's a possibility of the Australian fragments beneath the Ophiolites. And this is some of the evidence of the normal faults that cut those ramific rocks in the northern part of the area. So this one I did the field work with Joby Pertamina Medco and Somori. So yes, and we can say that the extension role actually happening right after the following after the collisions, and it's not only in the Miocene time, but it's still happening from Pliocene until the present day. And this is the evidence of the extension in Tolo Bay area. So this is the Tolo Trough, and this is the interpreted seismic session from Rudiawan and Hall, showing the extensional detachment within the pre-Neogene basement here. And this is some examples of the or evidence of the extension. So this is the in Bone Bay. If you can see Bone Bay, like there is no evidence of the truss at all. So the truss is only like in the eastern part only, while in this part, there is no trust or evidence of the compressional regime. So it's basically only dominated by a normal fault, and it's completely different what we can see in Buton Island in here. Okay, this is the another Pliocene to recent subsidence recorded by the reef. So this is bathymetry from the Gorontalo Bay. You can see there's a movement of the backstepping pinnacle, backstepping reefs or pinnacle reefs. That rise about 300 meter above the seabed, and it's not only in Gorontalo Bay, but this one in East Arm. We also got terraces of carbonate rocks, uplifted carbonate terraces, and I think there's also in Buton that indicating the uplift and also subsidence that still happen until now. So this is the seismic section in Tomini Basin. So this is the interpreted subsidence carbonate sediments. Even you can see here, there's a rift. This could be like, 2 kilometers depth. So there's a rapid subsidence happening right now. So this is the interpretations of the continuations of the normal faults in Pompangio complex. So from the seismic here, we've seen the Pompangio in online before, and then the seismic might also give us evidence of the extensional detachment faults offshore. And this is the magmatic and metamorphic ages. So previously in this map, the metamorphic rocks are interpreted to be like pre-tertiary or even Paleozoic, but recent dating by Juliana in Palu area indicating that there is a very young granite. So this is about Pliocene time, say late Miocene to Pliocene, 7 million years ago and 3 million years ago. So this metamorphic is actually really young, and also the granites in Palu area, they are really young, and then that also represents the young sediments, why they are like not well consolidated, because they are really young sediments. And when you have a rapid uplift, there should be rapid erosion that might lead to the rapid depositions as well. And this is another evidence of the rising Sulawesi. So here we got Malino Metamorphic Complex. So the Malino Metamorphic Complex is dated start about like middle Miocene by Albert, and then another extension event is happening about the Pliocene time. And this also the one that has been dated by Juliana. We got a very young, like 3 million years ago, granitoids, and the metamorphics like 3 to 2 million years ago is quite surprising how fast uplift in Sulawesi. And if we see here, this is the bathymetry that I saw you before, and you can see that this fast uplift also relates with the fast subsidence in Sulawesi. And if we can see in general, mainly the rocks that are exposed in Sulawesi are pre-Neogene rocks. So I feel like in Sulawesi is like got cursed, because there's no much sediments in this area. So it's really hard to get sediments, and they might be related to the rapid uplift in this area. So if you can imagine, if you got like previously you got sediments, and then now most of the sediment has gone, so they need to be like deposited or eroded and then deposited to the basin, right? And that's why I believe that the thick sediments in the basins around Sulawesi, for example, Gorontalo Bay and Bone Bay, they are dominated by Neogene sediments. So at least like, after the Miocenes, and then there should be like significantly increasing of sediment afterwards, at least after the middle Miocene up till now. So sedimentation should be high, and that could be a good good news if you're looking for a Neogene place in here. So here is the stratigraphy. Previously, people called the Celebes molas, or what they call the Celebes molas, as a very young sediments, only Pliocene, and there are new like studies that indicating that this should be like a, older depositions of Celebes molas, and then this is one of the reasons why I started my PhD, and then this is the reasons why they call Celebes molas, because it's named by the Swiss Alps. So basically only showing the characteristic of the loose sediments that looks like molas in Alps, and then they just name it as a Celebes molas, and they just put everything's like, uncomfortably above the pre-Miocene rocks, and without the correct or exact ages. So this is the revised stratigraphy. So I try to date all the what they call as syllabus molas, and then try to make it in the regional view here related to the tectonic event. So this is the revised stratigraphy across Sulawesi, and then this should be matched with the key tectonic events in Sulawesi as well. And I did that by different methods. So I did phases analysis, light and heavy minerals, like I saw you before, and then I also did the zircon chronology, and also did the biostratigraphy from foram, nanofossil, and fallen, and then also did the theoretical physics. And these are examples what I did in the field. So for you students, I think this is a good thing that you can do when you are doing your mapping or fieldwork. And then I try to say like in the bigger scale. After that, I can group them into different units. And this is the light mineral that I did. And then it's also helped me to detect this, like, the stratigraphy. You can see there's a big change here from the serpentinite rich unit to the quartz unit, correlates across this can be. And this is the heavy minerals that I did. This is where I can see uh, 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 the glaucophan, and also can see the lawsonite, and different kind of heavy minerals that help me to interpret the source. So yeah, this is the zircon dating that I did. So we got younger zircon that helped me, and you can see here that this zircon probably come from the zircons or quartz that contain zircons from Meluhu formations. And Meluhu formation is uh, uh, let's say it's part of the Sulaspo, or is part of the Australian fragment. So it's another evidence that Southeast Arm is actually part of the Australian fragment. And I put all the ages that I got from different analysis. You can see here, I put it all together, and then I managed to make a simple stratigraphy to correlate across the area. And this is the cross sections that I made. So this is my interpretations of the metamorphic core complex that possibly related to the extension of the Bonnet Bay. And this is the examples of the paleogeography. So my end product is the paleogeographic maps, and then after I get all the data, I plot the data in the georeference system, and then I try to correct what onshore to the offshore. So this is the examples where I can see the changes of the light and heavy minerals to help me interpret the paleogeography at that time. So this is the big changes from late Miocene to latest Miocene. There's a significant uplift, and then after that represent this subsidence that represents by the transgressive carbonates. So this is the examples. I don't think I have a time to explain all the paleogeography. So this is the examples that I did. Here I try to put all the data in a timely manner so I can see the evolutions of the Sulawesi Island. The one that I want to highlight here, the formations or the form of the Sulawesi itself, it's really young. You can see the even in 2 million years ago, it's not all part of Sulawesi are connected. So like at least like all connected in the 1 million years ago. So in the geological term, it's really a really young island. And so yeah, so what's the implication then? So and of course, the tectonic, active tectonic can give you the earthquake. So I think uh, Sulawesi is the one of the active areas in the world with the earthquakes. And then if we put the rapid sedimentation context with the rapid uplift and subsidence, so there should be like a big like unconsolidated sediments deposited in the basin. Then and it can also create the submarine landslides that make the tsunami. I think I'm gonna skip this one. And there's possibly because of the steep area and then unconsolidated sediments that can also make the landslides or mass movement. So we took this. You can see this took in Desameko after earthquake in there. So you can see is a big landslides in this area. And there was also liquefaction happen in Sulawesi. I think that one of the reasons is because of the unconsolidated sediments, and it's very young unconsolidated sediments, and also the steep slopes of the area as well. So that need to be like considers when we are in urban planning. So we need to get a better understanding of the geology as well. And this is what my map like used for. So uh, this map is surprisingly match up with the expansion of the Sulawesi water peak, Babirusa and Anoa. So it is one of the reason could be of the islands, like isolated islands that make them hard to like move to other islands. And this is the oil and gas. I compile all this data. So there's so many gas and oil seeps indications, but there's only like at least 3 areas that are proven. So in this area, and then in Sengkang, and then Buton area where it got proven hydrocarbon. So this is one example of the seismic, like I told you before. This thick sediment here is possibly like with the Neogene age. So there's a potential of the Neogene place in Sulawesi itself, and there's also possible of the Mesozoic place. And this is the clay types that commonly referred to in East Arm. So we got Neogene like Miocene, carbonates, and also we possibly got also Mesozoic rocks that have a potential. So this is the Buton. Pinto Formation is proven source rocks in Buton. In East Sulawesi, that might be related to the Tokala formations, and this is some of the evidence in East Arm which showing the Triassic cells that become the source of the hydrocarbons. Another thing that can be proposed is the Jurassic Meluhu and Southeast Arm. So this has also a Jurassic source rock and also Jurassic sandstones. And this is the a possible or proposed for the Neogene. So Miocene probably have a potential to produce hydrocarbons. Probably, I will show you the study later. And these are the potential of the Neogene rocks, at least in Bhutan. So in Bhutan, there is a proven Neogene source rock. So this is from the well. So indicating source marine shells, which is rich in Ulenana, and this is from the field. So both indicating that Miocene rocks can be a source rock in Sulawesi, and this is what I propose in this area. So they should like they could be like a two different big delta towards the Bhutan and the Bone. So if Bhutan's got a problem with the seal, so probably there's no problem with seal in the Bone Bay area, and there's also like a carbonate platform that can be a good reservoir in the area. And when I was in Pertamina University, I got a grant to do the research, social characterization for Bone Basin. So I was hoping to get like early Miocene rocks in the fields that I can correlate what. Unfortunately, we cannot get the early Miocene. So the oldest rock that we can get is light Miocene. So we trying to do the source rock characterization. So these are the list of samples that I collected, and this is the result of the geochemical analysis. So mainly not really good, although there are some that showing a fair source rock. So I'm still hoping that there should be a good source rock in the deeper offshore part of the Bone Basin that probably have the early Miocene age. So we tried to do the 1D basin modeling with my colleague Haria in Pertamina University. So here is the results. So we got like very limited sources. So we only can get this published well here in in northern part of Bone Bay. So we try our best to do this modeling, but here we can see that at least the lowest part or the oldest part of the middle Miocene can already generate oil. So we're still very positive that the early Miocene are also, I mean, most likely generate oil in the Bone Basin. So this is the petroleum system chart in Eastern Sulawesi. So there are two places in here. So I'm not gonna talk about Mesozoic this time, but I'm going to highlight the Cenozoics because of the rapid uplift and also rapid subsidence that's still going on at the moment with the rapid sedimentation. So there is a big possibility of the oil and gas accumulations in the Cenozoic sediments. So here's the discussion. So hopefully you can answer these questions, whether the timing of the collisions is early or Pliocene. After I show you some evidence, the recommendations should be like there should be more fieldwork in Sulawesi to check whether there are like wide distributions of the early Miocene rocks, and whether should be a subduction or there is also abductions. So you can check if there is Ophiolites in Sulawesi. So hopefully you can also answer that one. And hopefully you can also abandon the syllabus molars term because it's too general and cannot give you anything. So there are 5 mega sequences that can be traced across Sulawesi and consistent with the Neogene's extension related metamorphism, magmatism, and then structural events. And the stratigraphic events were mainly consequence of the rollback of the Banda and also North Sulawesi subductions. And the formations like land, mountains, and basin in Sulawesi are very young. And geoscience inputs are really important for contingency plan and also urban planning, like what I give example before. And for the oil and gas, especially for a Neogene, there's a proven source stroke. So I hope there's also some proven place in Neogene, but mainly in Tiara and in the southeast arm with the seals, and there's also Mesozoic. So I hope there should be like more studies about prospectivity in Mesozoic and also sediments. All right, thank you very much for keeping up with me.
Thank you very much, Pak Ega. Very, very nice. Very interesting. Okay, I 1.5 hour. That is very interesting. Very interesting. Yes, it's very, very interesting, Pak. Okay, I put the list of the question in the chat, Pak. So we can go through. You can just see on the last chat.
How can I find the chat here? Okay.
Okay,
Yeah.
number one is from Reza. Is
Yeah.
there any evidence related to the subduction extension transitions? Maybe some reactivation fault or something else?
Mm-hmm.
Yeah.
So about the subduction extension transition, so mainly in the fields there are some difficulties to the evidence that I can see. There are some that, let's say, in one outcrops there are evidence of truss, but there's also evidence of the extensional faults in there, and that's make it hard to interpret. But from the ages that I can get, and then some ages like from around the area as well, you can see that extension mainly happen in middle Miocene, and then I would say that the extension is the latest event of the uh, uh, of the tectonics
Okay.
in that time. Yeah. Yep.
Yeah. Okay. We can go to
Yeah.
number two, yeah.
Yeah.
Yeah. Mas Epo, Ega, thank you for your presentation. It's very, very good and very interesting.
Mm-hmm.
Yes, that's what I thinking also. I would like to
Okay.
confirm,
So.
according to your explanation, is that true that collision occur only on early Miocene, not
Oh.
Pliocene? After that period, is there any compressive tectonic happen in Sulawesi?
Okay. Thank you, Epo. Epo is my colleague when
Yeah.
I say determinism physically. Good questions. Yes, at the moment, based on the evidence that I got, the the hopefully we can date, because that I told you that we've got like blue cysts in the Pampangyo that we wanted to date, and it was of uh, a project with me and also Rio in Pertamina University. So hopefully there should be something came out from the blue cysts, and we can make sure the edge of the collisions. But from the southeast arm is showing that it's probably like no early Miocene. And then in the Pliocene, I have no evidence of the compression, let's say, of the collisions in the Pliocene, because it's morely around the area that even in the central Sulawesi, that there's a intrusion that related extension that been dated by Juliana in Pliocene time. But is there any compressive tectonic? Yes, but it's still related with the extension and event. So it's like it's really hard to explain it when it's got no picture. So for example, if you got uplift, right? So there's some part that have, you know, limited space. So in that part, let's say like mostly in the eastern part, like also a Bhutan. So the Bhutan is probably because you got you know many trust sequences in there. There should be a trust that or compressive regime that related with the extensional event in the southeast arm. So yeah, there's a compressive tectonic compressive regimes evidence, but it's still related to the extensional event in the regional context. Yeah,
Thank
that's
you. Number three, Purnama. Is there any systematic formula to predict scale of basins with related to rollback subductions in case of Neogene basin in Sulawesi?
the systematic for to predict scale of basin related. Mm, a little bit uh, confused with this question. What scale is it? The scale of basins in terms of the dimension or what?
Mas Purnama, you can turn on your audio if you go. Yeah.
I mean the main factor that having a bigger opportunity to creating a depression in the Neogene times.
Okay, the systematic formula, the best formula is get someone to drill the basin. Because there is no wells at the moment, especially like in the Gorontalo and also Bone Basin. We've got all a well in there, but it's just really shallow up into the lead mountain. So the first thing that we need to do is we need to make sure about the stratigraphy of the area. Because of that, I try to correlate what onshore to offshore because there's not much well data in the offshore. So we've got seismic line. For examples, I would say there's like a big difference of interpretations between Jablonski and Paul Booth in that time. So most of the thick like thick sediments in Gorontalo are Jablonski interpreted that might be contains like pre-Neogen sediments as well, but I don't think so based on the regional context that I've explained. So systematic formula, just like look at the bigger picture first, try to understand the regional geology, and then after that you can get into the basin. So try to make everything's in a good geological history. But for sure the stratigraphy is still is still questions in the offshore area. Yeah.
Okay, Mas Rebi, the fourth. Excellent talk. Is the extension still active today? Why the normal faults did not cut younger stratigraphy in your previous picture?
So the the faults is kind of like moving getting towards the in the pictures is like we got there are some even uh, uh, younger sediments that cut by normal, but that's commonly seen that close or in the proximity of of the core complex itself. And then even in the uh, east arm, it's still active. I can see that there are some what young sediments. I think I've got I've got it in the slides that also cut by normal faults. Oh yes,
Okay.
and as agency rollback is agency pretty massive formatting in there. What do you think? Oh yeah, it's kind of similar. So that's what I say. So the subduction rollback of the Banda mainly affecting most of the eastern Indonesia. That's another thing that can be reconsidered. I remember that I talked with Robert Holden, and he actually like wanted me to check the young sediments not only in Sulawesi but also in Buru and also Seram. So that's another thing that maybe we can do and try to revisit all the young sediments in the eastern Indonesia. A good one.
Okay, next question number 5, Pak. From
Yeah.
from Pak Erlangga. Can you see that?
Yeah.
Yeah. Mas Ega, thanks for sharing the new ideas in Eastern Sulawesi. The
Oh,
data
you're
supports this very
welcome.
sophisticated. There's a strange lineament pattern of volcano art in Tomini Bay,
Yeah.
northeastern arm in Sulawesi, ya.
Yeah.
Kemudian and Una volcano, which
Yeah,
are not
yeah, yeah,
normally
yeah.
aligned to the pattern of subduction zone in North Sulawesi. What do you think about it? About this
It's
formation
always
of this volcanic art? Could it be an evidence of the subductions rollback that create a crustal thinning, or could it be more locally
yeah.
fault related?
It's really good question. This is always like a talk about this una because it's not in the positions of the North Sulawesi trends because it's just right in the middle and it's only there. It's only one in there. So I actually have no idea about that. There might be, just like kind of a plume that come up of the because of the crystal thinning or crystal extension in the area. So I have no idea. Maybe I heard that someone, I don't know, from ITB have a study in Una volcano. So hopefully there might be someone that study this volcano, if what the origin of this Una volcano. Yeah, it's really weird. Yeah, thank you for good questions, but I don't know the answer. Thank you, Mas Erlangga.
Okay, number 6, Pak, from
Yeah.
Perdana. Jos presentasinya agak based, based on your schematic cross sections of passive abduction resulting sum of Ophiolite bodies sliding down to the east. Is that mechanism related to the gravity-driven edge shallow detachments? What is exactly the detachment level in this case?
Okay, Pak Perdana. I think we can talk this later. We're going to have another meeting tomorrow because we did our undergrad together. So yeah, so because of this mantle exhumations, and then it creates the vertical movement, and of course there's a limit of the vertical movement when the limits approach. The gravity will taking care of the sediments, and that's one of the reasons why they can create the extensional detachment faults. So yeah, there's a gravity driven effect on the detachment of the sliding rocks above the core complex. Yes.
Okay.
Thank you, Dan.
I hope you still have stamina to answer the question, Pak. Okay, number 7, Mas Afif. Always exciting to hear your talk. Based on your observation, what is the basement of a mini basin? Is it PMC or else?
Chomini Basin. So I would say I have a discussions with Alvin Rudiawan, who did his PhD in Northam, and he said is evidence there is a possibility of the Australian fragment beneath the Gorontalo. So I would say there is a chance. There is a chance of the at least in the eastern part of the Chomini basin is underlined by Sulaspur. But in the western part, I'm still not sure. But there's still study need to be done about that. So I would say there's a 50-50 between whether it's oceanic or it's continental basement under the Chomini basin. Yeah.
Okay, number 8 from Mika from ITB. In the last chat, yeah, you can see that.
Yeah.
Can you see that? Yeah. Hi Ega, what a great talk. Thank you for the sharing. One question from my paleontologist point of view, and Mike, a bit out of your topic today. Did Sulawesi start to take its shape as an or several islands and being livable for terrestrial lives? even before Pleistocene. Can we start first? Was it possible for land bridge to occur during that time? It is an interesting question since the terrestrial fauna we found in Sulawesi seems to be quite old.
Okay, yes. Thank you very much, Mika. I always love paleontologists. Just uh, I was a paleontology assistant during my time. So okay, I think I need this. I need to see the pictures in here. So whether it's livable before the Pleistocene, yes, I would say it's livable, but the land itself is very limited or very small, and that might also affecting the lives. I don't know. I've heard that with the small areas, probably you will get you try to become like the animals will become smaller, and then when you will like try to adapt with the small island. So yeah, before the Pleistocene it's still livable, but possibly there's like a big sea area that separates the islands, as you can see here. So which part first? Probably might be in this Western Sulawesi area, because in that time there might be like animals from Sunda lands like Borneo that can cross into the into the western part of Sulawesi. Was it possible for land bridge during that time? I don't think during the Pliocene uh, there was a possibility of the like land bridge in I think it started in Pleistocene, as you can see here, about 2 million years ago. Okay, the still fauna of Sulawesi seems to be quite old. So yeah, there might be so, but mm, there could be a good thing to talk later as well about this.
So
But
next
at least
we'll excavate the central part.
mhm, the central part. And what did you get there?
Thanks, Ega. For
Okay,
nice.
thank you.
Okay,
Okay, it's Sam with Mas Erlangga, right? Oh, nine,
yeah.
Rahmat. I think it was one of my students here. Current summer, we can see lots of violators. The stratigraphic wise is not so obvious like the one. Mm, I I think the Ophiolites in Karangsambung is quite uh good. I mean, in small areas, but in Sulawesi it's like more separates it's more separated. But yeah, there are some that is really good in especially the ultramafics in Sulawesi are really massive. What makes ophiolites that is found in Karangsambung different? So I think they are both ophiolites. In terms what the difference might be, the mechanism, I would say, because I got evidence of the extension. I'm not sure if the ophiolites in Karangsambung also related to the passive abductions or abduction that I explained related to the extension. During the is it possible that during the formation of each unsorted tectonic there is not as much of the one during formations in Karangsambung? I don't know. I don't have the answer for that one, whether comparable with the Karangsambung. But for sure, the mechanism possibly are difference. Okay.
Okay, we can continue from
Yeah.
my friend Edo ya.
Okay, Edo.
Hi Bang Ega, number 10. Hi Bang
Gimana,
Ega, hope
Dok?
you are doing well there.
I
I
hope
would
you're
like to
doing
make
well
sure about
too.
the definition of rollback. Okay, that you just explained. Is it correct? In order to create rollback, we need to have a slowing down movement of the oceanic crust to the subduction zone and an active extensional tectonic on the continental crust to fill the gap. Or is it possible to have a rollback? No need for the oceanic crust to be slower if the extensional faulting on the continental crust is extremely active.
So I would say that the continental crust for the overriding plate become extension is because want to accommodate the need to accommodate the movement of the hinge. So like you have a certain like volume, and then in that certain of volume you need to close the gap, so you need to extension for that. And slowing down movement of the oceanic crust. So I would say for this case the simplest way is like don't need to be slowing like very slow, as long as you have, in this case you have a really dense oceanic uh, that sinking or like going down, so it can create the the or it can trigger the subduction rollback. So I just give just uh, looking at the sample in example in here. So we've got, like I said before, the Jurassics, and then I got Cretaceous. So the Jurassic is possibly older, and when the oceanic between the oceanics, so the older probably have denser density, and then it starts to sinking faster, I think. Yeah.
Okay, thank you.
Hope that can answer your questions.
Yeah, you can chat Mas Ega if you have the question.
Yeah,
Discussion.
yeah.
11
I
from
don't
Pak
think
Andang.
Edo will have time. Yeah.
From Pak Andang, number 11 ya. Ega, how do you
11,
explain
is
the
it
offshore?
going down?
Sorry?
Okay. I need to go down. Yes.
Yeah, number 11 from Pak Andang ya. Ega, how do we explain the offshore Western Sulawesi thrust fault belt system in the overall rollback scenario of this eastern arm?
So on the uh, offshore Western Sulawesi thrust fault belt. Oh, I see now. So it's offshore Western Sulawesi is like the one that towards the Makassar Strait, right? So I don't get the picture here, but all the data that have been dated by Juliana, it's clearly showing that the granites is really young. So I would say that the offshore Makassar Western Sulawesi thrust fault belt is also related to the extension of this young intrusions in Western Sulawesi. So this would be like it should be like what Perdana asked before. So there should be relation with the gravity driven tectonic as well. So when you got uh, uplift in the offshore and western part of Sulawesi, and then it's also creates a kind of a gravity driven tectonics that makes the thrust and fault belt system towards the Makassar Straits. Yes, that one.
Okay, number 12. This is from Vicky Amir ya. Sorry, forgot to put your name. Hello Bang Ega, I like your presentation tonight. I want to ask question. I had field trip in east of Palu City with a geology lecture. There is an indication of melons surrounding by LT, metamorphic rock, chert, and one granite boulder. But we aren't sure because that outcrop is weathered. Is it okay if we say that melons?
Rick, that was not my question.
Oh no, this is from Vicky Amir, Pak. Vicky Amir. Sorry, I forgot to put his name. yeah. The is before. Yeah.
So when they say about melons, so we need to make sure whether it's like there's a tectonic melons or sediment melons here, and then if we say this melons, it should be like really related with the subduction systems, and we also need to know the dimension itself. If it's a tectonic melons, usually you will got like a shear sheared rocks that, you know, like like kind of a fish eye shaped rocks. We get that kind of a melange in East Arm, but I honestly never seen that in Palu City. So if it's tectonic melange, we need to check again, because even in the young sediments, I would say that I've mentioned that even in the present day sediments, we can get these like metamorphic rocks, cherts, and also granite boulders. So we have to put like extra careful attention when we put the specific terms for it. So yeah, maybe next time we can do the field work, and I mean, we can check it together. Yeah. Thank you for your question, but I will doubt about that.
Okay, last question from Mas Diki ya.
Yeah.
Hello Mas Ega, thank you for these interesting presentations. I have question. In your last slide, you mentioned that stratigraphy events were consequence of rollback.
Oh yeah. So kind of events, consequence of rollback. So is there any relation with the sediment routing system? Yes. So like what I give an example before, because of the exhumations where the mantle rocks and also the ultramafic rocks get uplifted, and then sometimes hard for you to get like a complete sedimentation records on land. So the only thing that you can try is looking at the like the last sediment that you can get. So from the last sediment that you can get, so you can get a record. So that's why I always like tells people that when we say provenance, it's not only like KFL, but there's also a detail in the heavy mineral. So you can check if there's any resedimented materials that can help you to interpret the stratigraphy or even the paleogeography. So if we don't know, like we don't understand the regional context itself, it will be hard to put the the sequence or correlations between onshore then and offshore. Then, and that's one of the tricky things doing geology in Sulawesi. So some people like will have a difficulties to correlate what onshore to offshore, because most likely in the offshore you will get like complete sequence, while you cannot get the complete sequence in onshore. So you have to a better understanding about the regional geology itself, and that's why the tectonics like more like let's say like severely affected the on land, where most of the oldest or basements get uplifted, and then that's why the understanding of the extensions or the rollback itself will help you to interpret or correlate the stratigraphy to the offshore. Yeah, I hope that answer your questions, Mas Diki.
Okay, I think that is the last question. Yeah.
That's the last question. Oh, thank you, Tampu. Just like what you want, right? 2 hours.
Yeah, this is as we planned before.
Yeah. You planned.
Yeah.
Okay.
Yeah,
Thanks very much for
FOSI,
listening.
I will say thank you very much, Pak. You have answered 13 questions. It's very
Thank you very
comprehensive
much.
presentation that you have.
Yeah, I hope
And I
people
will
don't get
go
bored.
to Melinda to close this.
Thank you very much, Ricky.
Thank you. Melinda, your time.
Yeah, Mas Ricky, thank you. Mas Ega as well. Thank you very
Yeah,
much.
thank you, Mbak Melinda.
It's such a thoughtful and fruitful discussion. If we are still waiting for the question, maybe we need another 2 hours to answer the questions as well. So thank you very much.
That's what Ricky planned, like, okay, we make it to 2 hours because like so many people want to hear, like, okay,
Yeah.
and then like we got more people.
Actually, we have 350 people that are registered for this. I don't know. I think there is some people cannot come.
That came up. Okay.
Yeah,
All right. Thanks
we are
very much
350.
anyway. Thanks very much. Thanks for people who's listening to me as well.
Yes, very interesting, Pak. Okay,
Yeah.
Melinda.
Yeah, maybe if anyone wants to discuss with you, if you don't mind, they want to chat you and send a message to you.
Yeah, send a message, and then you can send DM as well through my Instagram. Don't forget to follow me.
Yeah.
So yeah, feel free if you want to discuss anything, or you want to, if it's if like students want to ask, or you want to get some materials that I put on my presentation, I'm more than happy to share with you. Just drop me a message, DM or email to me. So more than happy to help. Yeah.
Yeah. Yeah, maybe later on we will add additional session for this Sulawesi. Maybe it doesn't to discuss in only 2 hours. Maybe we can discuss more time.
All right. Thanks very
Again,
much, Mama Linda. Hopefully, yeah. Hope people don't get bored.
Ega, sorry to interrupt. Do you have any further plan to do some more research in the area in place right now?
At the moment, fortunately, because I just moved to Singapore, and then rivers, my research group is mainly working in the big rivers, and then at the moment my boss, like, not thinking there's big rivers, but in the future I told them that I know Sulawesi very well, and then we should get a project there. But my next project will be on Mahakam, so hopefully I will in contact with the people who is working Mahakam. So I'm going to look for the quaternary evolutions of Mahakam River through the provenance. So yeah.
Is there any possibility that other company, in cooperation, have a cooperation with your company over there to do some research more in the Sulawesi?
I think so. I think as Observatory of Singapore, like, really open to have like collaborators or collaborations to have a project. So it's kind of because I think there should be like we can have like several like projects and at the same time. So only like we need to make it like, is it big or small projects. So yeah, I think there's a possibility to do that here in Observatory of Singapore. Yes.
Okay, thank
All right.
you.
Thank you,
Super.
Pak Andang. Thank you.
Okay, great.
Yeah, maybe yeah, at the end of session, and thank you so much also Pandang was here
Oh,
joining with
thank
us.
you, Pak Andang, for listening me till the end.
And many people from UK as well. So different time already.
Oh,
For
thank
2 hours
you.
different.
Really appreciate it for people who's like listening me to the end.
Yeah, and thank you to all participants. Keep their spare time to listen you until the end of the session.
Yeah.
And maybe last but not least, we also prepare for the next FOSI event talk on next Monday, where we will talk about basin modeling. Maybe later on we will discuss more on how to de-risk the petroleum exploration. So maybe once again, thanks to Mas Ega and thanks
Thank
to all
you.
participants. Stay safe and healthy and keep doing well during this COVID-19.
Yep.
And see you again in the next evening talk.
All right.
Once more,
Bye.
thank you so much.
Great
Thank you
talk,
so much,
great
Mbak
talk.
Melinda.
Super, Ega.
Thank you,
And thanks,
Pandang.
Fosi.
Thank you.
Okay.
Thank you,
Very, very
Fosi,
good.
and everyone who organized this.
Mantap. Luar biasa.
Sip.
Thank you, Ega.
Mantap.
Congrats, Ega.
See you later. So
Take
in
care,
the next
everyone.
talk. Yeah. Thank you.
Thank you, Mas Ega.
Ya, Mbak Melinda.
Ya,
Thank you ya.
lagi-lagi.
Bye
Bye.
bye.
Oke, I think we just end the meeting ya. Oke,
Ya.
thank you.
Thank
Semoga
you,
sukses ya
Ricky.
Mas ya, postdoc-nya.
Sama-sama.
Ya, stay safe
Sampai
di sana.
jumpa di lain kesempatan.
Siap, siap.
Thank
Ya.
you, Pak.
Oke.
Bye-bye semua.
Oke, saya end meeting ya. Oke.
Ya.
Thank you sekali lagi.